excuse me for a moment. Back to show me the v, absolute value. Good. Then we did square root. Do you remember what square root graph looks like, base graph? Maddie's got it back there. Anybody else? Colin had it, kind of, like he humored me. It's good, though. It's a swoop, right? The swoop to the right. So show me the swoop. Good. Then the second unit, we brought square root units back, and then we added in rational graphs. Do you remember all those different rational graphs? Do you remember what the names were? Volcano, show me volcano. This is always a fun one. Show me volcano. Yeah, that's good. What were some of the other ones? Show me sad clown face. Love it. What was the other one that comes up occasionally but not as often? So volcano, sad clown face. Graph with hole wasn't what I was thinking, but yes, because you can have a hole in anything. The one that was just like, speed bump, right? Just the little bump, speed bump. So we brought you those. And then last year we did all of our polynomials. So we took what you learned in grade 11 with the quadratic. Show me a quadratic. Show me a quadratic. We had cubics. Show me a cubic. Good. Show me a quartic. It's the W. Good. Quintic. Yes. What we're doing in this unit is taking all of those graphs and doing stuff with them. We're going to add them, subtract them, multiply them, divide them. Why? Because we can. Why wouldn't we do that? So that's what we're going to focus on today is the adding, subtracting, multiplying, dividing. We're going to do it graphically and algebraically. And then on Friday, we'll look at something called composition of functions. That's it. That's the whole unit. It's a teeny tiny little unit. So today we're going to do what's called combining functions. So adding, subtracting, multiplying, dividing. We're going to do it graphically first. And then in a bit, once we do that, we'll do it algebraically. Here's what you really need to know. To find the sum, difference, product, or quotient of two functions graphically, you must either add, subtract, multiply, or divide the values of the y coordinates while leaving the x coordinates unchanged. Okay, so when we combine functions, we only combine the y values. The x's don't change. So here's what a typical question might look like. Given the graphs of f of x and g of x below, find h of x if f plus g of x equals h of x, and plot it on the same grid. So this is the directions, what they're asking you to do. That's one way to write it. The other way they could write the same question is they might put f of x plus g of x. Okay? Both notations mean exactly the same thing. It means we're going to take the functions and add them. So we assume by the labeling that f of x is referring to this graph on the top and g of x is referring to the graph on the bottom. What kind of graph is f of x? It's a parabola. What kind of graph is g of x? Linear. Turn and talk, 30 seconds. What do you think's going to happen when we add a parabola and a line together? What do you think the resulting graph is going to be? Just turn and talk, guess. What do you think it's going to be? What's going to happen when we add a parabola and a line? Thoughts? What do you think is going to happen? We're just guessing at this point because you don't know. I heard a cubic. Cubic over there. I couldn't hear what you guys were talking about. Cubic. Everybody cubic? Okay, well, let's find out. This is a table the way my brain works to do this. You won't be given this kind of table in the question, but I'm going to show you how to walk through it. If you like that, great. If you have a different way, that's great too. So my brain works with the table. What I do first is I just pick some random x values. Typically, we pick some negatives, we pick 0, we pick some positives. So I'm going to stick with our normal -2, -1, 0, 1, 2. Just know those aren't the only values that you can use. You can use any x values you want in the entire world. Now, if you're visual, you might want to grab a ruler for this because it's a little bit easier, but it's completely up to you. So what I do to get the first value is I put the ruler vertically at -2. So passing through -2. And what I want to know is what are the corresponding y coordinates on both of the functions. And I'm going to do them in order, f of x first, g of x second. So you just need to keep track which is which. So I'll go to f of x first. What's the corresponding y value? I heard 4. Really 4? Is my ruler crooked? Oh, it's a little bit crooked. You're totally right. It's 4. Go down to g of x. What's the corresponding y value? -3. Now I'm just going to shuffle over to -1. Same thing, I want to know what's f of x, what's g of x. So what's the y value of f of x at x equal to -1? 1, I heard. And on g of x, -1. Go over to the origin. Again, you just can't lose track of which is which because f of x now is underneath g of x, so just make sure you're doing it in the same order. So f of x first, then g of x. What's the value of f of x and g of x? Coming over to 1, same thing, parabola first, line second. And the last one is 2. And again, you don't have to use these x values. You can use whatever x values you want. We just tend to pick some negatives and positives. Offer of 4 and 5. Confirm. So the table starts the same way no matter what this question is asking you. We just now do whatever the question wants. This question says to add, so I'm going to physically add these y values together. If it said subtract, I would subtract. If it said multiply, I'd multiply. So the first one, 4 plus minus 3 is 1. 1 plus minus 1. 0 plus 1. 1 plus 3. And 4 plus 5. And the reason I've shaded the outside columns is because these are what we're going to graph now to get that combination of the two. So your x values are on the far left and your new y values are on the far right. Again, you don't need to use a table. Some people can just look at the graph and get the point. That's okay too. So we've got -2 and 1, -1 and 0, 0 and 1, 1 and 4, 2 and 9. What was our resulting graph? It's another parabola. Didn't see that coming, did you? Why? Why is it another parabola? Why didn't it become a cubic? Well, if we think of the general term of a quadratic, we know that it's x squared plus bx plus c. B and c just being numbers. Maybe there's a coefficient here, whatever, it doesn't matter. And what we're adding to it is a linear function, which we know is mx plus b. Well, if we were to combine like terms, we would combine the two x's, and we would combine the two constants. So what we're going to end up with is a highest power of 2. The highest power we're ever going to get is an x squared. That's why this ends up being a parabola, is because when you're adding, is there any way to increase the exponent? No. What's the only way to increase an exponent? Is multiplying. Okay, so it's good to kind of know ahead of time what the graph should look like because it helps you kind of plot the points. So now you know going into this one it would have been a parabola. Questions so far on the first question? I know this is weird to add functions. It's new to you. We've never done this before. Okay, well, let's practice the subtraction. First thing I'm going to do is just darken f of x because the photocopier made it a little bit light. So I'm just going to retrace them so it's easier to see. Hello. I'm good. Are you here to do your spiel?
Yeah, are they ready to test?
Nope.
Online is that? One more message. Oh, more message.
Okay, turn and talk, 30 seconds. I want you to guess what's going to happen when we add an absolute value with a line. I meant subtract even though I said add, because we're subtracting. What's going to happen when we subtract a line from an absolute value? I heard someone say a line. I didn't hear that side again. What do you think? Just guess, just guess. This is just for fun. This is not for marks. Give you a hint, it's not a cubic. Not going to be a cubic. Okay, they're too shy. Okay, good enough. Again, pick any x values you want. It's totally up to you. I like, because I'm traditional and I'm left-brained, I like to stick with the normal ones. But again, you can pick any values you want. It's completely up to you. Again, just make sure you're really looking which is f of x, which is g of x, because when we subtract, that order is going to matter. I'm visual, so I like to go with my ruler. If you don't need the ruler, don't use the ruler. It's completely up to you. So go down to f of x first, figure out the y value. Offer of -7 and g of x. Okay, go over to -1. Over to the origin. That was quick. Over to +1. You should be able to figure out the pattern with the linear function now. And at 2. I just wrote down what you guys said, so confirm it, make sure it's correct. Okay, so again, these charts aren't going to be given in the question. You have to make one yourself if you want to do it. And then I like just to remind myself what we're doing up here, because your brain's going to want to add everything. But this is actually f of x minus g of x. So we're doing a subtraction. And then again, because I'm visual, I like to put the subtractions right here just so we won't get screwed up with negatives, negatives, or anything going on. If you're not visual and don't need to write them, don't write them. It's completely up to you. So -7, -2. -7, -2. -6 minus 1. -5 minus 0. -4 minus 1. -3 minus 2. Ooh, do you see something happening there? Strange. And again, just remember, if you're going to use the table, it's the outside values that you're now graphing. So go ahead and graph those 5 points. Why did I join them with straight lines and not curves like a cubic? Why did I choose to do connect the dots with straight lines? Thoughts on that? Check out the shapes of the 2 original graphs. What were they? Straight lines, so that's why I did this one in straight lines. If there had been any curves up here, I would have done this with curves. Let's talk about this flat part. That's really weird. Where did that come from? Why is it flattening out and always going to be horizontal right there? It's not because it's an absolute value. It's a good thought, though, but it's negative, so it's not an absolute value. You just have to remember what subtraction means. Subtraction is finding the difference between 2 numbers. And so here we've got quite a big difference. What do you see in the difference between these 2 graphs? What do you see in the distance between them? They're parallel, which means it's a constant distance. This is a constant function. So it's because these 2 sections are parallel that we're getting this flat line. So whenever you subtract an absolute value in a line, you're always going to have a straight horizontal line where this parallelness, I don't know if that's a word, might have made that up. Parallelness is. Questions so far? State the domain and range of this last graph. Got an offer of XER. We got an offer of y is less than -5 or equal to, y or equal to. Yeah, because there actually is points at -5. Show me your thumb so far. How are you doing with combining? I'm getting this, I'm kind of getting this, not getting this. Good. If you're here, that's okay at this point. We've done 2 examples. Let's do a multiplication. What kind of functions do we have here? We have a square root and a linear. What's going to happen when we multiply a square root with a linear? What's going to happen when we multiply a square root with a linear? Well, let's figure it out. Give me some x values. Let's pick some random ones just to do one differently. I know left brains, but let's be right brain for a second. Just like random it up. Let's go for it. I love it. -1. I like 0 too. Got to have that in there. Don't pick 1 and 6 now. That's too left brain. 2 and 3. Sounds good. Again, just to draw the point, you can pick any values you want. Now just be careful you're keeping in mind which is f of x and which is g of x. So we go to -6. Uh-oh. What do we do for f of x? It's not 0 because that's a value. Is there any graph over here? So this is a does not exist, an NA, a not applicable, whatever. There's no value there. If there's no value, there's no value. What about -1? Oh, I forgot to g of x. Sorry, I got so excited there. -6, we got to g of x down there. -9, I hear. Okay, now scooch over to 1s. That was our next value. Over at the origin. Over at 2. Is it 2 or is it ish 2? Ish 2. So do we want to put 2 or do we want to put slightly less than 2? Okay. We're okay rounding it to 2? Okay. Two and 1. Got to be -1, right? Because the g of x is underneath. And then over to 3. .2 as an approximation. Are we okay with that? And 0. Don't forget to fill in the top here just because it brings your eye back to what we're doing. What does this black dot mean? And I want you to make a note that it's a black dot or a filled in dot or an included dot, because next class we're going to look at what the white dot means, and mathematically they're very different. So black dot means multiplication. The other way you can write this is just the 2 functions next to each other. So f of x, g of x is the same thing saying multiply. How the heck do I multiply a does not exist times -9? Yeah, if it doesn't exist, it doesn't exist. It can't exist on the multiplication. It's not there. It's done. What's 0 times -4? 1 times -3? 2 times -1? And 2.2 times 0. And I just want to draw your attention to these here, the second point that we chose and the last point that we chose. What's special about those 2 points? There's 0, and what do we call a point where the y value is 0? They're x-intercepts. So if you look at the original, they're x-intercepts. If you look at the final, they're x-intercepts. So all x-intercepts will remain x-intercepts. So even if I hadn't chosen those random values, before I start anything, I can go to the graph and I can mark the 2 x-intercepts, and I know those are points on my multiplication. So even if we hadn't chosen them, I know they're there because they're x-intercepts, and when you're multiplying x-intercepts, stay as x-intercepts. Okay, I can't do the -6 dne, so I'm going to jump down to the 0, -3. And then I've got a 2, -2. So what the heck is this thing going to look like? Well, the first question is it straight lines connect the dots, or is it curvy lines? Has to be curvy lines because one of my graph was curvy lines. So it's going to come this way and hook up. So not quite a parabola. We actually call it a hook because it looks kind of like a fishing hook. Why does it look like that? So what kind of graph is this? Well, if we think back to the base graph, we know we would have had a root of x. It would have been translated over, but it would have had a root of x. And what we ended up multiplying it by was the x in the y equals mx plus b. And so we know way back from grade 10, root of x is actually an exponent. It's hidden, but what does root of x equal to as an exponent? Anyone remember? Root of x is x to the 1/2. And when we multiply bases, what do we do with those exponents? When we multiply bases, what do we do with the exponents? You add them. So this is actually the graph of an x3 on 2, or an x of 1.5, which you've never seen before. It's got a hook shape to it. So it's halfway between a linear and a parabola, which is kind of cool. How are we feeling so far? Okay, let's do some algebraic ones. So this time we're not going to have the graph, we're just going to have the equations. So to find the sum, product, quotient, whatever, blah, 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 of two functions algebraically, you must add, subtract, multiply, divide the two functions, then simplify. That was maniacal. So find f of x equals f minus g of x if f of x is blah, 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 some quadratic, and g of x is blah, 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 some quadratic. Okie doke. Question wants us to subtract them. How do I know it's a subtraction? Because it's got a little subtraction sign. So all I'm going to do is physically take the functions and subtract them. So my first function is negative 3x plus 5x minus 8. Then I'm going to put a subtraction sign and put my second function, which is 4x squared plus 2x plus 6. And then I'm going to grab my red pen and put brackets around the second one. And why are those brackets so important? Because this negative has to apply to everything in here. So whenever you're subtracting, just make sure you throw some brackets at the back because now I need to distribute this negative. So this is actually just a grade 9 collecting like terms. The first 3 terms aren't going to change. And then I just want to distribute that negative. So we're going to get negative 4x squared, negative 2x, negative 6. And then just like in grade 9, we put the x squareds together. How many x squareds do we have? And then we take the x's and we put them together. So I have 5x minus 2x. And then I put the constants together. So I have negative 8, negative 6. Negative 14. That's it. That's subtracting functions. You've been doing it since grade 9. You just didn't know it. Questions so far? What the heck is this? What is going on there? Don't write this, just follow me. Functional notation way back from grade 10. So I'm just making this up. Linear function, that's a 3, although it doesn't look like a 3. So we just added this notation in grade 10. Remember we did lines, lines, lines in grade 10, and then the last year we were like, oh, f of x means the same as y, and we were all good with that. And then we were like, ooh, f of 1. Remember that? Right? And at first you were like, what? And then we're like, it just means subtract, or just means substitution, right? You take out x, you put in 1. So we learned in grade 10, this just means that we take out that x, we stick in the 1, we would simplify, which in this case is 8. And then we were like, ooh, negatives. Right? And that was the same thing. We would just take out x and we'd put in negative 2. So if I substituted negative 2, what would I end up down here? Negative 1, right? Remember this? And then we were like, ooh, let's put an m in there. And you were like, what? We're like, no, no, it just means the same thing. You take out x and you put in m, right? So this function would become... And then we were like, ooh, like let's put smiley face, because it doesn't matter what's in the brackets. Whatever's in the brackets, you take out x and you put in whatever's there. So this would become... 3 smiley. So remember all that from grade 10? Same deal here. Is this means take the subtraction and substitute 2. What's going to happen is your brain is going to look at this and think that's a multiplication of 2. Because that's how we kind of see multiplication, is brackets next to brackets. If we wanted you to multiply the function by 2, we would have stuck it in the front as a coefficient. If we wanted you to multiply by 2, it would have been in the front. It would have been 2f minus g of x. So just be aware this is exactly what we did before, which means substitute. So this question is saying substitute x for 2. Okay? Not a multiplication. And it's what your brain is going to think at first, because we're so used to brackets next to brackets, meaning multiply. All this question is asking you to do is take our subtraction from part A, take out x, and put in 2. How do we simplify this? So what do we do first? Brackets, okay? So go to the brackets. Is there anything we can simplify in the brackets? Nope. What's after b? Exponent. So I'm going to do this 2 squared first, and I'm going to cheat and just write it above so I don't have to rewrite everything. So 2 squared is? Now I have a multiplication here, and I have a multiplication here, so I'm going to do those first. Negative 7 times 4. 3 times 2. And I'm just going to collect the like terms, and like we've talked in other units, is you don't have to actually do these from left to right. If your brain puts the negatives together first, then go with it. If your brain's doing left to right, go with it. Go with whatever your brain does. My brain takes the negatives first. It's just what it sees first. So I go negative 28 and negative 14. I know that I really have to add them, so that gives me negative 42. Then I add 6. So really what I do is I take 42 and I take away 6. Negative 36. However your brain sees to put those together, put them together. If you want to do the negative 26 plus 6, that's fine, then the negative 14, whatever. Do you understand what this notation is asking you? Again, your brain's going to want to multiply because it's what it looks like. If we wanted multiplication, the 2 would be in front. Okay, we've done addition, we've done subtraction, we've done multiplication. Let's do a division. Here's what division notation looks like. Find f of h of x if f divided by g of x using f of x equals x plus 3, and g of x is 2x squared minus 5x minus 3. Division works like this. Take whatever they said was the top function, put it on the top. So that's f of x. Take whatever they said was the bottom function, put it on the bottom. That's it. That's a division. What kind of function is this? Here's a hint. We spent a half unit on them. So what do we call, that's when we analyze the degree, well, what's this group of functions like this called? Starts with an R. Rational. These are rational functions. High five. Remember the first 5 letters? What's the first 5 letters? Ratio. And what's the same thing as a ratio? Fraction. So this is just back to unit 2. That's all it is. It happens to be a rational function. State the NPVs. What the heck are NPVs? Yeah, so at the bottom, this is when we found or vertical asymptotes and whole, so same idea here. So let's factor the bottom. Agree? Disagree? Really, really quiet? So x cannot equal? And negative a half. So although the question didn't ask, we can just review quickly from Unit 2. What do you know now about x minus 3? It's going to be a whole, and what do you know about the x equals negative a half? If it's not a whole, it's a vertical asymptote. The question didn't ask, but now we know. Find f of 0. What the heck does this mean? Substitute. Take out x, put in 0. So go to our f of x function. Every time we see an x, we take it out. Offer of 1. Like a slight nod from Casey, like a little bit of a nod, not like a real nod, but like, so she's like got your back like just a little bit. Anyone else want to confirm this? In terms of graphing, what did we just calculate? The y-intercept. The point of this is we did all of this in Unit 2. We're just renaming it as combination of functions because we divided. There's nothing new in this. Woo, questions? Of course not. You'd never ask me a question. You barely talk to me. Although you're